Okay, hello all. For my multimedia project, I will be examining and comparing three popular audio streaming platforms. Three services I've chosen to look at are Spotify, Apple Music, and Tidal. There are a few reasons why I've chosen these. First of all, because Spotify and Apple Music are the most popular services in use. Secondly, because the technicalities between all of them provide an interesting look into the realm of audio compression. You get to see open source and proprietary formats, as well as lossless and lossy formats. All the bases are covered. Audio compression will be the only point of comparison, not UI, song library, or any other extra features. And the format of this presentation will be as follows. First, look at Spotify and the Vorbis format it uses, then Apple and AAC, then Tidal and its two hi-fi options, FLAC and MQA, and then finally I will demonstrate some audio compression tools. Spotify can deliver formats and bit rates based on subscription tier and which application you're using, but the standard for the highest tier subscription on the desktop and mobile app is Vorbis format at 320 kilobytes a second. Vorbis is a free and open source audio format. It's commonly used with the .ogg container, so some people call the file type oggvorbis as a result. Its coding technique uses the modified discrete cosine transform, MDCT. It's a lap transform, which means the blocks that are converted to frequency domain overlap some wavelength with each other, avoiding artifacts along the boundary. Then the data is split into noise floor and residue components and quantized according to a codebook or lookup table based vector quantization. Vector quantization is a form of non-uniform quantization where a probability density function and vectors are used. And following is Apple Music. It's not a large wealth of information on Apple Music, but it's known to deliver standard content at 256 kilobytes per second in the AAC format. This stands for Advanced Audio Coding. It's not open source, so it's somewhat subject to patent license. Developers of AAC codecs must have a patent license, but no payments or royalties or anything are required to distribute or play AAC content. AAC is part of the MPEG-4 audio standard. It's the audio component of an MPEG-4 video file is usually encoded in AAC. AAC also uses the MDCT. Then the frequency data is quantized based on a perceptive model. And the LunMod-M algorithm is used for error detection. This is the sort of idea, it's like a checksum or something like that for each audio frame. AAC also has options, including error resilience, low delay, various other profiles and other things as well. Same as Vorbis. So finally, we get to Tidal. Tidal is somewhat newer. It offers a high subscription tier where you can get FLAC, and another higher one where you get MQA. They make the claim that MQA is superior to FLAC. Can it really get better than lossless? FLAC stands for Free Lossless Audio Codec. It's free, open source, which is the same as Vorbis. It's actually managed by the same non-profit organization as Vorbis, ziff.org. It's a lossless format, so no information is lost during the compression process. You can expect a FLAC file to be about 50 to 70% the size of its original WAV file. The FLAC uses linear predictive coding to convert the audio, and then the difference between the predictor and actual data is stored as the residual using golomb coding and run length encoding to compress and store the residual. The size of the file can change based on compression options, but this doesn't affect the quality of the file, just how much processing power is required for efficient compression, decompression, and the speed at which it processes and encodes the file. Finally, we will discuss MQA, which stands for Master Quality Authenticated. This format is a partnership between a bunch of companies, big companies, similar to the MPEG, Motion Picture Experts Group, that kind of thing. Technically, it uses lossy compression. The higher frequency bands are compressed and stored in the lower ones, or something of that nature. There's some touch upstream store which encodes the difference. For sampling, a triangle function is apparently used. I think this has something to do with sparse sampling or compressed sensing, which is some advanced signal processing technique. But even if MQA is as inventive as it says it is, and it sounds as good as they say, there's significant criticisms being raised. That is that MQA could create a form of monopoly. The MQA shareholders get paid at each step of the recording, manufacturing, and playback process because the playback hardware requirements and licensing requirements may be designed in that way. Something to consider. So to summarize, Spotify's choice, Vorbis, is free and open source as well as lossy. Well, Apple's AAC is also lossy, but it is proprietary. And Tidal uses both an open source lossless and a proprietary quote-unquote lossy that supposedly sounds better than the rest. There's no best choice, but my personal opinion is that free and open source software is usually the best option, especially in an area related to the music industry in general, which is dominated by a few large corporations. Next, I will do a live demonstration of audio compression. There doesn't seem to be a way to test MQA, so this will be FLAC and Vorbis and AAC. So let's go. Now, this window here in the corner, there is a one wave file here. The size is 46,000 kilobytes. And we're going to compress it. The first one we'll use is AAC. Now this is a command line program called Nero AAC Encoder. The options are as follows. This is 256 kilobytes. The number, or kilobits, the number of bits. The input file, and this is what we're going to call it. And let's let it run and see what happens. Okay, 270 seconds later, we have our file. So you can see AACout.mp4. It's 8,500 kilobytes. So next, we're going to use our Ogg Vorbis converter. So we're going to drag our WAV file to this fish, and it's working. It's making our Vorbis file at 320 kilobits per second, same as Spotify. And we get our results, track1.ogg, which comes to 11,000 kilobytes, 11 megabytes at 0.4. Finally, we have our FLAC front end. I've loaded up the track. Encoding options here could be used to set the level of compression. I'll leave it at 5, which is the default. Okay, let's encode. Popped up a little window. And now we have our file, which is here. As we can see, the total size of the file is 28.4 megabytes, a significant reduction from the original 46.6 megabyte WAV file, but without any loss. That concludes the demonstration and the presentation. Thank you.